Now, boiling point elevation. So remember that solutions will boil at higher temperatures than the solvents. So that means by adding solute, it allows you to boil at a higher temperature. It takes a higher temperature for your solution to boil off. So adding antifreeze, even though it's antifreeze, notice there's a section that says boil over protection. That means that by adding your antifreeze, you're actually protecting your car from overheating as well. So even though it's antifreeze, technically, by putting that ethylene glycol, that solute, in your radiator where it's supposed to be, this actually will protect your car from overheating. So same kind of concept, just the opposite way. So you have firestorm and also heat wave from DC. So, all right. Alrighty, boiling point elevation, delta TB. So got the Human Torches and also right there. So delta TB equals KB times molality times I. So I will give you the KB. It's constant depending on the solvent though. So it may be a different solvent than water. So you have to read it carefully. Molality again times I. So to get your new boiling point, you got to take the boiling point of the solvent and add your delta TB to it. So we're going opposite. Before we subtracted, now we're going to add to it. All right, what's the boiling point of a 0.75 molal solution of urea in water? The KB for water is 0.52 degrees Celsius over M. Urea is a non-electrolyte. So delta TB equals KB times M times I. KB is 0.75. Oh, sorry, I apologize. KB is 0.52 degrees Celsius over M times your molality times 1 because it's a non-electrolyte. So 0.52 times 0.75 times 1, 0.39 degrees Celsius. So your new boiling point will be higher, so you have to add it to the original boiling point. So this is water. The boiling point is 100 degrees Celsius plus 0.39 degrees Celsius equals 100.39 degrees Celsius. So for sig figs and all that, just give me two numbers after the decimal, and that should be okay, because if you rounded whatever, you won't be able to see the actual difference in temperature. So just keep that in mind for this. I won't be too picky with the colligative properties, just be careful though. Alrighty, what is a boiling point of a 1.50 molal solution of KCl2? Kb for water is 0.52. KCl2 is an electrolyte. So remember that CaCl2, it breaks up into a calcium ion and 2 chloride ions. So that's 3 for your Van Hoff factor. So delta TB equals KB times M times I. So 0.52 degrees Celsius over M times 1.50 M times 3. So 0.52 times 1.5 times 3. So 2.34 degrees Celsius. So your new boiling point, or actually we're just calculating for the boiling point elevation, so therefore you're done here. If I ask for the new boiling point, then you need to add it to 100 degrees Celsius because we're dealing with water, but it's just the boiling point elevation for this one. All right, good. So one way of looking at it, just to summarize these two particular properties, you add a solute, and the range in which it can be a liquid is increased, if you will. Adding solute to a solvent, it will boil at a higher temperature, and it will also freeze at a lower temperature. That's the general thing you want to focus on in terms of this stuff. So keep that mindset in mind because hopefully it will help.